had a mystery on our hands this week. The scholars in this room are the crew of the mighty ship, the Envisioneer. While in search of an ancient treasure, we were marooned upon an island, and a key part of our navigational map went missing. Of the crew, 4 suspects were considered. Today you'll hear the evidence against Dr. Smart and Shipwright Neff.
Since people were getting hurt with supplies flying all over the ship, they used splints so the limbs that were hurt stayed in place to prevent further injury. In class, we learned about splints and slings. When putting a splint on someone, you have to have layers. The first layer should be the layer that allows the limb to stay in place while it's healing. The second layer should be a soft layer to hold the first one in place.
So we didn't have enough splints to go around the entire crew, so we actually used a few slings. A sling is a cloth that actually supports the injured limb and kind of goes around the neck. So, and the crew members also had different types of fractures. There was the simple, open, closed, and comminuted. So the splint that is right here on my arm is called a sugar tong splint. It's got the needed layers. The first one is the layer to keep my arm stiff from moving. And the second one is to hold that layer in place.
Chief Stowe was one of the crew members that was injured. She was shortness of breath and she was wheezing, which is a sign of a collapsed lung. So we made a collapsed lung. When you pull the diaphragm, the lung gets bigger. When you release it, it gets smaller.
In building this model lung, we definitely had evidence that it was definitely a collapsed lung. A collapsed lung is basically when there's a pocket of air between the lung and the chest wall. It's treatable, and you can put a chest tube in through a surgical procedure.
Okay, we needed the M-bot to signal where the survivors were by using piano sounds and flashing lights. I started by separating the tools, the screws, and the nuts, and then I assembled the main power, which is here. I added the motor, the sensors, and the ultrasonic sensor and the battery. I then added the exterior, like the wheels, and screwing on the power source using the golden brackets. I then connected the wires and I was done.
After we built the robots, we then had to code them to save the crew members. To do this, we made them do a distress signal, which consisted of lights and playing a certain note. As you can see, our robot is doing that right now. We did this past Tuesday, and I personally thought it was a really cool experience.
We had to build a bridge to save crew members Sidney Young and Robert Neff. We had to use robots to get to them because the area they were in had a flood which made it inaccessible to humans. To build the bridge, first we needed to get the measurements for the robot. Its height was 4 inches, its length was 6.5 inches, and its width was 5 inches. We then built the bridge, making its dimensions a little bigger than the robot's, being the height in 5 inches, the length 12 inches, and the width 8 inches. We built the bridge out of paper, tape, straws, and paper clips. We bent the paper clips in a certain way to fit into the straws so we could connect them. We decided to go with a triangle pattern to make it the sturdiest we could possibly do. Overall, the bridge worked and we were able to get the robot safely across it.
When we were making our bridge, our main focus was getting Sidney Young and Robert Neff. The flooding made us have to build the bridge and get to the island. I will now show you my robot crossing the bridge.
We learned about the heart because during the investigation, Chief Stewart had symptoms like shortness of breath, wheezing, and an accelerated heart rate. Cutting into the heart was difficult because of the thickness of the muscle. The outside of the heart was filled with tons and tons of fat that also included different parts of the heart. We were assigned to locate the vena cava, the right atrium, the right ventricle, the pulmonary artery, the aorta, the pulmonary vein, the left atrium, and the left ventricle. However, we did not find the right atrium or the right ventricle. We learned that the vein carries the blood in and the artery carries the blood out. If we ever need to examine a human heart, I would know better where everything is located and what it does, and I could come up with a better treatment.
On the outside of the heart, it was slimy, but it didn't look like it. When you looked at the outside of the heart, you could see the little veins. When you cut the fat on the outside, there was a gritty cream texture to it.
In class, we learned about different types of snake bites and different possible effects. We also learned the best treatment based on the wound.
The red-tailed green rat snake is non-venomous, but it has a painful bite. It is 7.5 feet thick. It can be green, silver, and brownish, but it is usually bright green. It can climb trees, and even though it's called the red-tailed green rat snake, its tail is usually not red.
The king cobra has a neurotoxic venom. It's the longest venomous snake in the world. It can reach up to 20 feet long. If it needs to, it can lift its whole body off the ground to make eye contact with a human. The bite causes pain and swelling and general muscle weakness that leads to paralysis. Usually shy, but can be very aggressive.
The Malaysian pit viper has a triangular head and a stocky body. It is 2.7 feet long. It is reddish-brown, and it's venomous. It is hematoxic, which means if it bites you, it will affect your blood. It rattles its tail before it attacks. It jumps when it attacks, and when it bites you, it causes immediate pain, swelling, bleeding, and tissue damage.
The banded crate has a neurotoxic venom. It's black with yellow bands and can get up to 6 feet long. Unless startled, it will only attack at night. The bite is fatal, leading to being paralyzed or respiratorily paralyzed. There is little pain or swelling. During the investigation, there was a blood spot on deck. In order to find out where the cut was on the person, we dropped blood from 12 to 30 to 66 inches high.
These are the results. You can see here's the blood spatter from 12 inches, 30 inches, and 66 inches. The measurements are different because they were dropped from different heights.
Crime scene, there was a powdery substance that did not dissolve in water, and it was safe to apply to the skin. We ended up figuring out that this mysterious powder was cornstarch.
To find out that it was cornstarch, we used iodine, water, and vinegar on powdered sugar, baking soda, cream of tartar, and cornstarch.
The cornstarch reacted the same way to iodine, water, and vinegar as it did to the mystery powder. When iodine was applied to it, for example, both powders were like a sticky substance. We came to the conclusion that the mystery powder and cornstarch were the same thing.
Now we have to figure out who stole the missing piece of the map. We examined the cups that had the fingerprints on it. After we had to determine if it was Dr. Nicholas Smart, First Mate Sidney Young, Shipwright Robert Neff, or Howard Potter. The fingerprints helped us find out that it was Robert Neff and Dr. Smart who stole the missing piece of the map. We figured out that the partners stole the map because we looked at the style of their fingerprints and matched it to the style of the cups. Dr. Smart had loose and Neff had whirls. After analyzing the cups, we figured out Dr. Smart was Neff's accomplice.
Based on the evidence that our STEM group found, we believe that Dr. Smart and Shipwright Neff are guilty of stealing the ancient map.